Hi, my name is Neil Joshampole, and I'm bringing you this presentation on OLTP Data Modeling for Beginners. It's just an introductory lecture, and it doesn't go into any of the details. However, it will give you a basic overview of the things involved and on how an OLTP data model is developed. Okay, so the first question before we get into OLTP development is, what is an OLTP? An OLTP is basically short for your online transactional processing database. It is the database your users interact with directly. This is the first level of the database that interacts directly with your web application or your application. It stores live, up-to-date information. So if you were thinking in terms of insert, update, and delete operations, the majority of them will occur on this database. This is the database that has the most rapidly changing information in it. So basically, if you have a blog and you're entering a blog, this is the database it will go into directly. It's your front-end database. It contains live, up-to-date information. Okay, so let's begin talking about the design process. This is an example of a small OLTP. What this OLTP or this database does is basically keep track of a company that deals with shipping and products. So it could be used for, let's say, a store that wants to keep track of its shipping and suppliers and shippers. So with this OLTP, it starts off with products. So we have products, and products have properties, as you can see over here. The properties would simply be columns in a table. So products have categories, as you can see here, and so then they have a relation between a product and a category. So all categories have information about them too that's unique to them, like category name, a description, and a picture. Whenever you have a product, you're going to have a supplier for that product. So you're going to have a relationship between a product and a supplier. So as you can see here, the suppliers have properties like its company name, its contact title, address, blah, blah, blah. Also, when a product is getting ordered, it's going to come from a shipper. And the shipper is going to have orders, as you can see over here. And the orders are going to have details like customer ID, the employee ID. So the order is related to shippers, since the shippers have orders. Order details like quantity, unit price, and discounts are going to be a property of orders. So you can see a relationship here. And then all products are going to be a result of order details. So as you can see, basically it has a table, these different entities that are shown here. And by entity I mean category or supplier or shipper or order detail or product. They have different properties which get their own table. This line will represent a relationship between the tables. So basically the OLTP is split up into different entities and the relationships between those entities. By splitting it up this way, you can have as much information separated as possible and minimize the redundancy. There are methods to further minimize the redundancy, and however, this is basically how OLTP is set up. This is one example that I got off the internet. Now, here's an example I made that is a little bit more simple, but I think it's a bit more clear also. So I made a OLTP for an apartment. This is the front-end database that would deal with everything that goes on with an apartment. So I'll have an entity for apartments. I didn't include any of the attributes of the different entities. So I'll have apartment. Apartments are gonna have rooms. So there's gonna be a relationship between apartment and rooms. Rooms are going to have tenants. So we could have a table for tenants, and this would have information about the tenants. Apartments could also have employees. So apartments will have employees. So there's a relationship between apartment and employees. And employees will have employee salaries. So this is another entity. Apartments can also have maintenance. So that would be a separate entity, and maintenance will be provided by a maintenance company. So that'll be that'll have information about the maintenance company in this entity, which my mouse is over, and they have a relationship between the two. And then all rooms will have payments, so there will be payment info for that entity. And as you can see, it's a bit abstract, and there are different ways to set this up. For example, tenants could be merged with employees into people. And I'm sure that you could probably think of different ways to set it up. However, it is based on experience and having modeled database from before that you will be able to see the different methodologies that are best for setting up your database. It'll also depend on your front end database and your application, how you want to access that information, and whether more or fewer tables will be better. By using more tables, you can eliminate the need for unnecessary data or unnecessarily complex tables. However, it's really that simple. They'll have naming conventions for naming their employees, and there might be a few more things involved, but it all varies, and it's really a matter of personal choice and reducing redundancy. So this is how it's set up on average. It might take a little bit of thought to get that into your head. You might have to do a little bit of reading on better design or people's preferences on design, but this is how I look at it. So now there's something called normalization that is done with OLTPs, or the front-end database. So what is normalization? Basically, normalization is the process of organizing the fields and tables of a relational database to minimize redundancy and dependency. It usually involves dividing larger tables into smaller and less redundant tables, defining relationships between them. Basically, you want to isolate data so that additions, deletions, and modifications of the field can be made in just one table, and it'll be propagated through the rest of the database through defined relationships. So that's why you have relationships through them. So you won't have to have multiple tables and update different fields in different tables again and again. So for example, if I have my name in one table, I don't want to have my name in another table. Okay, so they're forms of normalizations, or steps in normalizations. They call them normalization form. Normally, while there are more than 3 normalization forms, people normally only normalize to 3 NF. So the first step in normalization is eliminating redundancy and duplicates. By this, you go through the rows and the columns, and you eliminate duplicate columns and duplicate rows and duplicate data, right? It's as simple as that. So if you have redundant data anywhere, you get rid of it. Second, you get rid of partial dependencies. By this, I mean if you have a composite key is simply a primary key. I'm hoping you know what that is before getting into this. A primary key is basically a unique key for a particular table that is used to identify each of the rows. A composite key is a primary key that is composed of more than one column. So what 2NF does is it finds that certain columns in a row may be dependent on only part of a primary key when it is a composite key. So when that is the case, you want to get rid of those partial dependencies, because you don't want a table to contain columns that are only dependent on part of a primary key. So you would take that column and that part of the primary key and separate it into its own table and get rid of partial dependencies. In this way, it'll reduce redundancy. It takes a little bit of thought to understand that, but I think you could read up on it and understand it a little bit better yourself. Then you have 3NF, and that basically gets rid of transient dependencies. These are columns that are dependent on other columns that are not primary keys, which are dependent on your actual primary key. So it's an indirect relationship. So basically what you can do is take that column that is dependent on another column that is not a primary key, separate it into its own table, and you will have that non-primary key be a primary key in the new table that you separated out into. This will reduce redundancies also. So a transient dependency is basically a column that is dependent on a non-primary key column for its data. And that is a quick introduction to OLTP data modeling. I hope this helped you, and that is all for this lecture.